Hello everyone, this is Mr. Mohammed Hussein from Allure International School, your grade 10 Algebra teacher. Welcome to week 9, chapter 11, lesson 9, normal distributions. Here are the objectives of the lesson: to use a normal distribution, to sketch a normal distribution curve. Now let us see at the key concept of the lesson. In a normal distribution, 68% of a data fall within one standard deviation of the mean. 68% of a data fall within one standard deviation of the mean. That means to the right and to the left of mean, it is 68%. And again, 95% of the data fall within two standard deviation of the mean. At the same time, to the right and the left of the mean, there will be 95% data which will fall in two standard deviation. 99.7% of the data fall within three standard deviation of the mean. Same thing is true to the right and left of the mean. There will be 99.7% of the data which will fall in a three standard deviation. A normal distribution has a symmetric bell shape centered in the mean. A normal distribution has a symmetric bell shape centered on the mean, which means the right and the left side of the bell will be similar. This is a graph which shows the normal distribution curve. This green line or the green graph shows the normal distribution curve, and the midway of this curve is indicated by mean, so it is symmetric to each other, which means this is the image of this one or this is the image of the other one. So mean must be in the mid point of the curve. And again, the data in one standard deviation is to the right 34, to the left 34. So between in one standard deviation means between -1 and +1 deviation. So the sum of the two will give you 68%, as we discussed about in the slide above. And again, within two standard deviation means between this point and this point. That means the total percentage between the two will be the sum of this plus this plus this plus this, and it is about 95%. And within three standard deviation means between this point and this point. So adding all these percent will give you about 99.7%. One standard deviation, it is 34 plus 34 is 68. Two standard deviation, this plus this plus this plus this, which is 95%. Three standard deviation, as I have said earlier, the sum of all percentage until here, it is 99.7%. There are three kinds of distributions, as you can see from the figure. The first one is different from the second one, and the second one is different from the third one. We call the first one positively skewed because to the right side it is the shape is skewed, but here it's almost straight line. And second one, it's normal distribution or normally distributed because the left and the right hand side are equal or symmetric to each other. But this is not symmetric because this image is different from this one. And third one is negatively skewed because it is the curve is tilted down from the left side, but here it's almost right straight line, and this is not the image of this one, and so they are not symmetric to each other, so it is skewed to the left. Now let us see some examples analyzing normal distribution. Analyzing normal distribution, the height of adult American males are approximately normally distributed with mean 69.5 inch and standard deviation 2.5 inch. What percent of adult American males are between 67 inch and 74.5 inch tall? So to solve this problem, we must use normal distribution. Normal distribution is given approximately normally distributed. Here it's given that. So the mean is 69.5, but the standard deviation from mean is 2.5 inch. So we are going to solve the percentage of adult of American males that are between 67 inch and 4.5 inch tall. One standard deviation, we know it is 69.5 plus or minus 2.5. Since the mean is 69.5, we need to add 2.5, which is standard deviation, or subtract 2.5 to the left. So it will be between 67 and 72. To the right of mean, it is 72. To the left of mean, 67, within one standard deviation. Again, within two standard deviation, 67 minus 2.5 and 72 plus 2.5, because 67 that we obtained from the one standard deviation to the left of the mean. Again, we go to the left, we deduct 2.5, and again to add 2.5 to 72 within two standard deviation, and we will get 64.5 from this and 74.5 from this one. In three standard deviation, again you need to subtract 2.5 from this one, from two standard deviation, and you need to add 2.5 here. So it will be 62 here, and this is 77. Then put these numbers in order, which means what you have obtained from 1 and 2 and 3 standard deviation: 67, 72, 64.5 and 74.5, 62 and 77 in order as 62, 64.5, 67, 69.5, 72, 74.5, 77 on normal distribution curve. So in the above slide, we calculated the intervals of deviation: 62, 64.5, 67, 69.5, which is mean, 72, 74.5, and 77. And then we know that the percentage of one deviation is 68, 34 plus 34, and the same thing for two standard deviation is 13.5 plus all this range, this plus this plus this plus this, and the three standard deviation will be the sum of all these numbers up to here. Then our question: the probability that the height of American adult male is between 67 and 74.5 will be that is, you will take the range between 67 and 74.5. That means including this part. So it is 34, which is 0.34 plus again 0.34 in decimal plus 0.135, which will give you 0.815. So this is the probability of the height that the American adult male will be between 67 and 74.5 inch. From the same problem above, part B, in a group of 2,000 adult American males, about how many would you expect to be taller than 6 feet, which is 72 inch? The probability, the height greater than 72 inch will be the portion which is greater than 72. In the previous slide, we know that in the normal distribution, the portion which is greater than 72 is 13.5% and 2.35%. So we need to add the two portions together, which means 0.135 in decimal plus 0.0235, which equals 0.1585, equal to about 0.16. This is the probability that the American adult males are taller than 72 inch. Finally, we need to multiply the probability that we obtain here with the total number of adult American males to find the number of those adult American males which is taller than 72. 0.16 times 2000 is about 320 males to be over 6 feet tall.